Hey guys, I hope you are having a great day today without me. Think of me on my way down south where it's going to be super hot. But you guys are almost done and you will have a great weekend. So let's go through this sample chapter test, and you can fast forward through this if you um, don't need help with a particular problem. But number one says use transformations to explain how to obtain the graph of y equals 2 times x minus 3 squared minus 5. Okay, this should be pretty easy for you guys by now. I feel like we've been doing this for a minute. What happens first? Let's see, we move right 3. Right, and that's right here. Move right 3. Move down 5. And then vertical stretch this 2 right here. Vertical stretch factor of 2. Yay! Let's see, what about number 2? Number 2. Identify the vertex and the line of symmetry for the function y equals 5x squared minus 2x plus 7. And then the easiest way to do this, of course, you can always graph it, so that's going to be your go-to. But if you remember, the line of symmetry for our function here has a formula, and that is to find x, it's negative b over 2a. So in this particular function, it is positive 2, because positive 2 is negative b, over 2 times a, which is 5, 10 equals 1/5. Okay, that's going to be the x part of your vertex, which we call hk, right? So 1/5 is going to be the h part of there. So if we have this parabola here, x equals 1/5 is going to be the line right there, the line of symmetry that goes up to the vertex. Now we just need to figure out what the y value is here, or the k value. So all we have to do is we take that 1/5 and we put it back in for x here. So 1/5 squared minus 2 over 1 times 1 over 5 plus 7. So 1/5 squared is going to be 1/25. So 5 over 1 times 1 over 25 minus, let's see, let's reduce this. So this becomes 5 over 25, which is just 1/5. So it's just 1/5 anyway, right? 1/5 minus 2 over 1 times 1 over 5 is 2/5. Okay, plus 7, but let's go ahead and give 7 a denominator of 5 too, since everybody else has a denominator of 5. So it's going to be 35 over 5. So 1 minus 2, they all have the same denominator, so it's going to be over 5. 1 minus 2 is negative 1, plus 35 is 34. So our, I'm going to move back up to the top and put our vertex as 1/5 and 34/5. And the line of symmetry obviously is this x equals 1/5 right here. And that's our line of symmetry. Okay. Again, if you want to remember any of this, write it down in your notes because you can use those for the real test. All right, you guys, question number 3 is kind of like that landlord one that we did before, where he was raising the rents and it ended up being like $1,500 for a 1-bedroom apartment, I think. So we're going to have a quadratic relationship here, and you can either start off like Travis did, I think, where he just created the equation based on the word problem, or we can create a table for what's happening. And I'm going to start with creating a table just so you can wrap your minds around what's happening here. So our X stands for the number of increases. Okay. Increases. And our Y is the revenue, how much money they're making, or how much money they're bringing in, right? The profit would be how much money they're making, but we're just talking about revenue here. Oh, that's cool. Look at that, what I just learned how to do. Okay, so that's so cool. If we don't increase at all, what's happening in the problem? It says an average of 90 lunches are sold per week for $6. So 90 times 6. That means our first amount of money that we make is $540. Okay. Then it says if we increase, each time we increase by 25 cents, the number of customers or the number of all-you-can-eat lunches goes down by 3. So instead of $6, we're going to multiply by 625, right? And instead of 90 people, we're going to have 89 people. So what is our new, I'm going to do this on the calculator really quick. 89 times, oops, it's not 89, right? It's 90 minus 3 people, which is going to be 87. Some of you have probably been yelling at the computer that I made that mistake right there. It's minus 3 people for every 25-cent increase. So 87 times 6.25, and that's going to be, so they're going to make more money even though they're selling less, a little bit more money. 543.75, right? And then if we increase it again by 25 cents, this is going to be $6.50. And then over here, we are going to go down 3 more. So instead of 87, that's weird that that just like deleted. Instead of 87, we're going to go down 3 more, which is going to be 84. Okay, so then you have 84 times $6.50, and that is $546 even. Okay, so we're going to keep going on like this, and I think I have the, I have the table here. After 3, it's going to be 546.75. After 4 times, it's going to be 546. After 5 times, 543.75. Now, you could enter in your X values, and you guys, on my paper, this 3 was there, just FYI. And go ahead and enter into list, so you would hit stat, edit, the X goes into L1, so in L1 you'd have 0, 1, 2, 3, 4, 5. Then in L2, you can put the revenue. Then, when you're done with that, hit stat again, arrow over to calc, and then do 5, quadratic regression. And it's going to give you a equation that you can use for this in order to find the maximum. Or what you can do is, I think if you thought about it like Travis did that one time, the equation we could put right here is that we start off with 90 people, but we lose 3 every time it increases, times, let's see, times $6 is what we start off with, plus we add on to $6 25 cents every time we're increasing. Okay, so that would be our factored form of the equation. The calculator, if you put it into the calculator and do the regression, will give you the standard form of that equation. Either one should work. You can either put that back into your y equals and find the maximum there, or I think we found it right here in the table. It is, if we raise the price 3 times, our maximum is going to be 546.75, but double check that with the calculator. The other question on there is, how much would the lunch cost in order to maximize our revenue? So that would be, it was $6.75 right here, right? This would be 81 times $6.75. So to maximize our revenue, we raise the price 3 times. We'll end up selling to 81 people. The price of the lunch is $6.75, and our maximum revenue is $546.75. Okay, you guys, I had you on pause while I went to the Desmos calculator. So I can show you this because I don't have any other way to record what this would look like. So I just graphed x cubed minus 9x squared plus 23x plus 1. And as you can see, we have one, see if I can move my mouse, maximum right here at about 19. And one minimum right here at about 13. And then it looks like it crosses at 0, 0, and the y-intercept is 0, 1. So let me know if you have any trouble with your calculators. Otherwise, you can go ahead and sketch this graph on number 4. Number 4, yep. Okay, and it looks like number 5, finding all of the zeros of that function requires us to divide the polynomials, and we did not do that. We decided not to do that. And number 6 is straight up divide those polynomials, so we're not going to do that one either.